What's good, math family? In this video, we're going to review how to properly multiply exponents. We have about 15 examples, so this is going to be a complete review for those who need it. When we talk about multiplying exponents, there are two key rules we need to be familiar with. So the first one is going to be like this. So we have x to the a power times x to the b power. And because they have the same base, we are just going to add our exponents. This is the first scenario. The second scenario, we're going to have a base with an exponent and we're going to raise it to another power, meaning multiplying the exponents. So the second rule, our answer would be x to the 6th power. These are two rules you have to know. So when we look at our first example now, 3 to the 4th times 3 to the 4th, same base, we just add the exponents. So after we add, we're going to get 3 to the 8th power. Now in the second example, they wrote it a little bit different. And when we look at this, all this is saying is y to the 8th times y to the 8th times y to the 8th. So when we look at this, we could have just multiplied 8 and 3 to get y to the 24th power. Or if we wrote it like this, or they gave it to us, like what you see in red, we could just add those exponents and we'll get the same exact answer. So please be mindful how they could write that. If we look back at the first example, they could have wrote 3 to the 4th power squared. And once we multiply those two, we would still get the same answer as 3 to the 8th power. Now in problem number 3, we have a fraction. Just remember to apply this exponent both to the numerator and the denominator. So once we simplify, this is going to give me x to the 8th power all over 3 to the 4th power. Now in this problem, we're going to have to simplify 3 to the 4th power. So the final answer would be x to the 8th power all over 81. We cannot simplify this fraction. This is the fraction in lowest terms. Now, problem number 4, same exact thing. 2 to the 3rd times 2 to the 8th, we have the same base, so we just need to add the exponents. After we add 3 and 8, we're going to get 2 to the 11th power. Another thing that you are going to see with properties of exponents are coefficients. So let's get started. So when we look at our first example, number 5, please remember that anything to the 0 power is just 1. So for question number 5, the answer is just a to the 3rd. Once we multiply a to the 3rd times 1, we get the same exact answer, a to the 3rd. But now number 6, when we have coefficients in front of the variables, we have to multiply. So we multiply to get 15. And then when we look at our base of x and we combine it, x to the 4th times x squared, we add to get x to the 6th power, and this would be our final answer. Now, another thing that they're going to try to do is they're going to put parentheses, making you think that you have to multiply your exponents. But sometimes this is not correct. It would only be correct if we had a number on the outside of the parentheses like you see on my screen. So in this problem, same thing. We're going to multiply coefficients to get 8. And then after a to the 3rd times a to the 7th, when we add those together, we're going to get a to the 10th power. And this is our final answer because we cannot simplify. Question 8, though, however, there's going to be an additional step because of this negative exponent. So when we start this problem off, we are still going to combine those exponents. But just remember that we have a negative, so that will change the answer a little bit. So when we combine -6 plus 2, we're going to get 8 to the -4 power. So what I'll tell you is let's just take the reciprocal before trying to actually take 8 to the 4th power. So now once we take the reciprocal, exponent becomes positive now. So we have 1 over 8 to the +4 power. Now at this step, I'm going to say to you, hey, let's go ahead and take 8 to the fourth power. And once we do, this will be 1 over 4,096. And this will be the final answer for this problem. And now we're going to go on to the next set of problems. On to number 9 now. One thing we have to be mindful of is this z to the 0 power. First off, we know that when we simplify this, this is just going to be 1. And when we look in the first expression or the first parentheses, we notice that there is no other z. So that z to the 0 power, there's nothing to combine it with. So when we focus back on x, right? Same thing, we're going to add those exponents. So this turns into x to the 3 plus 7. We get x to the 10th. Y to the 4th times y to the 6th gives us y to the 10th. And z to the 0 power is 1. We do not need to put that 1 there. This would be our final answer as a result. Now the next problem, very similar to the last one, we have a negative exponent. But luckily for us, after we add 4 and negative 3, we just get a to the first power. And we should already know we don't have to put that 1. That is understood. So the correct answer after we combine those exponents is just a. Now, question number 11, what they like to do sometimes is to give you more than one expression to combine. So just be mindful that after you combine, there may be an additional step. So once we combine these first two, we're going to get x to the negative third power times x to the third. So when we add these two now, this is going to give us x to the 0 power. So our final answer for question number 11 would just be 1. We know anything to the 0 power is 1. That is the final answer. Now, question number 12. The reason sometimes students get this wrong is that they're mixing exponent rules. Remember that right here, we're going to take negative 2 to the second power. Then we're going to multiply our remaining exponents. And the best way to do this, family, is let's take care of one step at a time instead of trying to mix everything together. And this is what I mean. So once we distribute that negative 2, we're going to have negative 2 to the negative 2 power, x to the negative 6, y to the positive 8. I like to do it like this sometimes so that we don't combine too many steps at one time. Now from here, we know we have negative exponents and we cannot have that. So we're going to take the reciprocal for 2 to the negative 2 power, x to the negative 6. Y to the 8th will remain the same. So once we take this reciprocal now, we have y to the 8th all over negative 2 to the positive 2 power and x to the positive 6 power. So the last thing we need to do to get this correct is evaluate negative 2 squared. And when we do that, the final answer would be y to the 8th power all over 4x to the 6th power. And when we look at our answer and we double check, we notice that there is nothing for us to simplify because we do not have similar bases in the numerator and denominator. And now we're going to go on to the last 4 problems of this video. If it has been helpful for you so far, family, smash the like button for us. Really helps out our channel and videos. In the next problem, family, we have to start off by multiplying our coefficients. So once we multiply 6 and 4, we're going to get negative 24. Then we go to add our exponents, but please be mindful of this trick. We're adding negatives. So this is going to be x to the negative 12. Then when we get over to our y values, we're going to have y to the first power when we do 3 plus negative 2. Now, the only issue right now with this problem is that we have a negative exponent for x. So what we have to do at this step is to take the reciprocal of only that negative exponent. And as a result, we're going to get negative 24y all over x to the positive 12 power. And this is our final answer. There's nothing more that we could do to simplify this fraction. Now, the second example, This becomes challenging because of this negative exponent. But the best way to do this is let's simplify the fraction, then we could take care of that exponent on the outside. So when I simplify this, we divide 3 and 9 by 3. So this turns into 1 over 3. When we combine our bases of a, please don't make this mistake. We have -2 minus -4. So we know when we subtract a negative number, it turns into addition. So we should have a to the positive second power. And then with our base of b, we know that anything to the 0 power is just 1. So as a result, b to the 5th power is going to stay the same. Now that we took care of that, we can now take care of the negative exponent. And the best way to do this, I would say, let's not even worry about this 1 here because it's not going to change the value. So when I multiply my exponents now, we're going to have a to the -4, b to the -10, all over 3 to the -2. So when we take the reciprocal of this fraction, oops, should be the other way, this is what we should have. 3 squared all over a to the +4, b to the +10. And to get this to its most simplest form, just simplify the numerator, which will give us 9 all over a to the 4th power, b to the 10th. So this is method 1 for completing this problem. The other way that you could do this same problem is like this. The second method to do this same problem is us taking everything to the -2nd power, then simplifying the fraction. So once we distribute that -2, we're going to have 3 to the -2, a to the +4, b to the -10, all over 9 to the -2, a to the +8, and we know b to the 0 is going to stay b to the 0. So we'll just leave that b. We're not even going to include it. So now from this step, let's go ahead and let's simplify this. Meaning we're going to take the reciprocal of all our negative exponents. So when we take that reciprocal now, this is what we're going to have. We're going to have 9 squared, a to the 4th, all over 3 squared, a to the 8th, b to the 10th. And when we take this one step further, this will turn into 81, a to the -4, because we did 4 minus 8, all over 9b to the 10th power. So now when we go ahead and we simplify, we start off with our coefficients, 81 and 9. And when we simplify that, we're going to get 9, right? Still have a fraction, 9's on top. And then we know that a to the -4 comes down to the bottom, so it's now a to the +4. And b to the 10 is going to stay the same because there's nothing else to combine it with. And when you look at both of these answers, we had the same exact thing. So it's just good to know, pick whichever one works for you. And now we're going to go on to the next example. In problem number 15 now, this is a little bit more simple because we don't have a fraction. We're just taking everything to the 3rd power. But the biggest mistake students make with this is sometimes they'll do 3 times 3 rather than 3 to the 3rd power. Please try not to make that mistake. So we know this turns into 27, not 9, x to the 6, y to the 6. We multiply the exponents, but the coefficients we're going to raise to that exponent power. Now in problem number 16, same exact thing. All right, we have 2a to the 3rd, b to the 4th, and we're raising it to the 5th power. If you come in here and you put 10, that is wrong. 2 to the 5th power is going to be 32. Right? 2 times 2 times 2 times 2 times 2. Then when we go ahead and multiply our exponents, a to the third times 5, or raised to the fifth power, is going to be a to the 15th. And then when we do the same thing with b to the fourth times 5, we're going to get b to the 20th power. And this is going to be our final answer. Really hope that this review on how to multiply exponents was helpful for you, math family. If it was, smash the like button for us. Subscribe to the channel and leave comments down below if you had questions on this video or if there's topics you'd like to see on our channel in the future. Thank you guys so much for watching Algebra 1 with Mr. Peters.